A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
We can see different types of number patterns when we go through various concepts of mathematics. Different types of number patterns or number sequences can be seen even in our daily life. Let us take an example. We can see some students are standing in a school assembly. These students are standing according to their heights. This is a sequence, right? Let us consider another example. If we examine a calendar, there also we can see different types of sequences. 1, 2, 3, 4 and 5 are the numbers arranged in order if we consider a row of calendar. These are counting numbers, right? Similarly, 2, 9, 16, 23 and 30 are the numbers in a particular column. What is the rule applicable on these numbers? Yes, it is starting from 2 and increasing by 7. Any column in any calendar of any month satisfies this condition. That is, examine the calendar of any month, we can see the numbers that is 8, 15, 22, 29 below 1, right? We already saw the numbers below 2, that is 9, 16, 23 and 30. Below 3 or below 4, it is interesting to observe that this particular order is satisfying. In lower standards, we already studied about even numbers, that is 2, 4, 6, 8 and 10. Starting from 2, this sequence continues to increase by 2. Similarly, in odd numbers, we can see the pattern similar to even numbers, that is odd numbers start from 1 and continues to increase by 2, that is 1, 3, 5, 7 and 9. If we consider the place value of numbers, that is there is another sequence, the sequence of ones, tens, hundreds, thousands and so on. What is the rule that follows in this series? This is a series of numbers multiplied with 10 starting from 1. All the sequences we observed here were written according to some particular rule, right? Which means that any sequence has its own set of rules and that rule may not be evident at first glance. Let us observe another sequence, that is 0, 1, 1, 2, 3, 5, 8, 13 and 21. What is the general rule in this sequence? Consider any two consecutive numbers in this series. The sum of that two consecutive numbers is the next number in this series. For example, adding the numbers 2 and 3 gives the number 5, where 5 is the next number of 2 and 3. Similarly, adding 5 and 8 gives 13, where 13 is the next number of 5 and 8. This particular sequence has various characteristics and this series is known as Fibonacci series. Breeding of rabbits, number of seeds in sunflower, number of ribs in some species are some examples of Fibonacci series. It is interesting to learn more about Fibonacci series, but here we only considered the concept of sequential arrangement. Let us consider another sequence, that is the sequence of 1, 2, 3, 4, 6, 8, 12 and 24. Is there any order satisfying in this sequence? Initially, it seems like this is a sequence of counting numbers, but gradually that pattern is lost. Then, is this not a sequence? As I said earlier, it is important to find out is there any particular rule satisfies in this sequence. If we analyze this sequence closely, we can observe that the elements of this sequence is factors of 24. That is factors of 24 written in a chronological order. We were about to conclude that this sequence doesn't satisfy any general rule, right? Then it is important to find the correct rule based on the terms in the sequence.
Now let us consider another situation of formation of sequence. An iron sphere is falling down as shown. The speed of this sphere is increasing every instant. If the speed at t seconds is taken as v meter per second, then the time speed equation can be written as v is equal to 9.8 t. If the distance travelled in t seconds is taken as s meters, then the time distance equation can be written as s is equal to 4.9 t square. If we consider the speed in each second, for the first second the speed will be 1 into 9.8 which is equal to 9.8, and for the second the speed will be 2 into 9.8 which is equal to 19.6, and for the third second the speed will be 3 into 9.8 which is equal to 29.4. Similarly, for the fourth second the speed will be 4 into 9.8 which is 39.2. So here the sequence of speeds that can be written as 9.8, 19.6, 29.4, 39.2, etc. Now let us find the distance travelled in each second. If we consider the distance in each second, for the first second the distance will be 4.9 into 1 square which is equal to 4.9, and for the second the distance will be 4.9 into 2 square which is 19.6. The sequence of speed starts from 9.8 and increasing by 9.8. Similarly, the sequence of distance is starting from 4.9 and multiplying 4.9 with the squares of counting numbers.
That is, if a set of numbers that can be written as first, second and third based on any such rule is called a number sequence.
We can form the sequence from characteristics of numbers. For example, if prime numbers are written in order given as shown, which is 2, 3, 5, 7, 11, 13, etc. Prime numbers are the numbers which have only two factors, the number itself and 1. Now let us consider another sequence. Here we can see a sequence of natural numbers ending in 1. That is 1, 11, 21, 31, etc. Similarly, a set of numbers written like this as first, as second and third according to some particular rule is called the number sequence.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.